Hello students, I welcome you all to Current Affair Lectures by Azad ICS Academy, and today we are going to study the current affairs of 18th February, right? So let us see what are the important topics that we have for today. The first important topic that we have is lightening the pollution burden of thermal power states. See, the title itself is talking about environment ecology topic, right? It is talking about how there is a burden, especially for those states which are depending upon the thermal power. Okay, it is thermal power plant. Now let us see what is it all about. It is related to the pollution and degradation, right? And we'll discuss more in detail about this. So thermal power producing states bear pollution burdens while supplying electricity to consuming states. They lack compensation, creative environmental and economic disparities. So let us understand why we are discussing this, what is the reason, etc. Okay, so we have to understand that what is happening here is there are some states which are able to produce electricity using the thermal power plant, right? And there is a kind of a pollution burden that they are facing, okay? And they lack compensation also. They are not getting proper compensation so that they can do some kind of environmental and economical disparities also. So we'll discuss about how this particular thing is happening, why there is this kind of disparity or there is this kind of burden. We'll discuss that. Okay. In the first updated nationally determined contribution under Paris Agreement. See, I think all of you know when we have discussed, I think in many classes we have discussed about what is nationally determined contribution. See, what happens here is in the Paris Agreement, what they decided here is that every country will come up with their own targets and their own targets will be set by the same country itself. Okay, it is depending on them whether they how much they want to reduce, etc. And that is nationally determined contribution. Okay, to UNFCCC, that is United Nations Framework on Climate Change. In August 2022, India has committed to first adopting a climate-friendly and cleaner path to economical development. Okay, the first thing that India has adopted in its nationally determined contribution is that it want to be environment friendly. See, every country for that matter want to be environment friendly and want to follow a cleaner path. The reason is because we all are seeing that there is a lot of global warming and it is going to have a devastating effects on our, environment, and that is over a period of time going to affect us only, right? So hence we have to understand that India is primarily depending upon what? It is depending upon understanding or making sure that we are depending on the cleaner energy or cleaner path for the economical development. And second is to reduce the emission intensity of its GDP by 45% by 2030 from 2005 level. The third is achieving about 50% cumulative electric power installed capacity from non-fossil fuel based energy sources by 2030. So what are the other things that it want to, like reduce? So it want to reduce GDP emissions. So means whatever emissions that are happening, we want to reduce the intensity by 45%. There are three important things that we need to understand. First is that we want to depend upon the cleaner energy or the cleaner path. And the second thing that it is talking about 45% of the GDP, I mean emission by 2030. And another important thing that it is trying to talk about here is and achieve 50% installed capacity. So we want to depend on non-fossil fuels. And how much we are depending on non-fossil fuels? 50% of all our energy will be depending on non-fossil fuels by 2030. Okay, along with other six commitments. There are other six commitments, but in this particular article, they are highlighting about these three here, right? Currently, thermal power plant has dominant share in India's electricity basket. Under a new regime, thermal power plant will also have a 50% share. So we'll discuss about this. So despite these goals, what is happening here is even after having all these goals also, the problem is that currently also you can see that thermal power plant has a dominant share in electricity in India. Means in India, you can see which particular sector is dominant. It is thermal power plant. And if we are discussing about thermal power plant, how is this thermal power plant? Now, let us understand the meaning of this particular thermal power plant. In thermal power plant, your coal or any kind of non-fossil fuels will be burnt. And when that is burnt, automatically what is going to happen? There is going to be a lot of emission. So even after we are having these kind of targets, are we able to meet these targets? Obviously, no. The reason is because we are still depending on thermal power plant itself for electricity in India. Okay, under the new regime, the thermal power plant will also have a share of 50%. So we have to understand and expect it to still retain. So even after having all this thing, still we are expecting it to be 50% share only, even in the new regime as well. So now we'll discuss a little bit about the facts. What are the facts that we have? So the agent of emission. So it is an agent of emission. We all have to understand. See, the thermal power production results in the huge amount of carbon emission because we are burning coal or other fossil fuels. The power producing states bear a burden of all the pollution and provide electricity to consuming states. So, who should pay the pollution burden of thermal power plants? This article is basically talking about the same thing. So now there is one state which is able to, produce this electricity, and it is only bearing all the burden. And if there is any other state who are taking the electricity or borrowing electricity from other state, they are not having that much of burden. So they are asking about the same thing here, that who is supposed to pay the burden, or who is supposed to take the burden of this particular pollution. Because this article is also talking about the same. Now we have to understand a little bit about facts, and what is the facts that we have to understand is the total installed capacity in India. So the total power that we have in India, or the total installed capacity that we have, is this much. That is 4,56,757 megawatts, in which the center sector has 22.9% share. Okay. And state sector has 23.7% share. Okay. And the private sector entities that we have is 53.4 percent of the share. Okay. So out of the total electricity generated capacity from the thermal power plant, so here we need to understand, out of this energy that we have generated from the thermal power plant is, so see, this is the total amount, and you can see more than or less than 50% is from the thermal power plant itself. That is 2,37,268.91 megawatts. Private sector power plants have the capacity. So here you can see that the capacity, so much of capacity is among what? It is among the thermal power plant itself. Okay. So this is something that we need to understand, and this is something which is not a good sign if we want to, go on a cleaner path. And out of this, we have to understand that coal is something that is very, very important. The reason why we are discussing about coal is because coal is the major reason, or major, what you want to say, source of thermal power plant. Okay, so we need to understand coal accounts 59.12%, okay, of India's energy supply. So whatever India's energy supply is there. So here you need to understand, according to the Ministry of Coal, Government of India's April 1, 2023 report, the total reserve of coal in India is this much, that is 378.21 billion tons, of which Odisha alone accounts 94.52 billion tons, around 59.12 of the total energy supply in India. So please understand, this is an important number here, that is 59.12% of the total energy supply in India is just from coal. So whatever electricity that is being generated in India, 59.12% of the total energy that we are getting in India is just from coal. India is around 73.08, that is this much billion units, and of electricity is generated from coal, oil, and natural gas respectively. So here you can see that what we are able to understand here is that the coal is the major source of our electricity that we are generating in our country, and which is not a good sign, because whenever there is burning of coal, there is emission of carbon dioxide, and carbon dioxide is a greenhouse gas. It is going to, be a part of a global warming, etc. So this is something that they want to highlight in this particular thing. Okay. So in 2022-2023, okay, 73.08% of the coal was electricity was generated from coal, oil, and natural gas. So this is what they are also trying to tell us, right? This is what is being told respectively in 2022-2023. Thus, the thermal power plant sector remains a major contribution of coal carbon emission in India. So in India, why there is so much of carbon dioxide emission? It is because of the coal power plants or thermal power plants. Okay. So this is something that we need to understand. Thermal power is a major contribution of the emission for the electricity generation. It's quite understandable from here. Now, we also have to understand, according to the Central Electricity Authority, Maharashtra has a highest non-renewable electricity energy capacity. So how much it can generate? That is 31,510.08 megawatts, followed by Uttar Pradesh, followed by Gujarat. In 2022-2023, Rajasthan has the highest renewable energy electricity generation capacity in India for installation capacity. Despite having the highest electricity generation capacity, some states consume more than their generation. See, these are the states, okay, which can use non-renewable energy, and renewable electricity energy. Okay, so these are, even after having this much amount of capacity, still they are depending on, means this is a possibility. Okay, this is a possibility that this particular state can, use this much amount of this thing. So hence these are what you can say states which can do better, but still they are not able to do better. This is what they're trying to basically tell us. Okay, states producing the most electricity do not necessarily consume most of it. For example, Uttar Pradesh consumes only 40% of NTPC's produced electricity. So what we have to understand is, for example, let us assume there is a state, if it is producing, all of that is not consumed by the same state itself. Okay, so it will be that is, so here you can understand thermal electricity generation by National Thermal Power Corporation also shows that state producing the maximum electricity do not consume most of it. So, for example, Uttar Pradesh, Odisha, Chhattisgarh only consume 40%, 38.43%, and 29.92% respectively of the electricity produced by their NTPC in their respective states. Gujarat is the biggest consumer of NTPC producing states. Despite the state's merger generation of 17.17 megawatts of NTPC, Gujarat and Maharashtra purchases electricity from different states from what is produced by the central sector and in other sectors as well. So what we have to understand is Gujarat is the, please make sure that you are able to remember this. Gujarat is the biggest consumer of NTPC producer electricity. That is nothing but, despite generating this much itself, despite it is generating its own energy, but it's still depending on other states for the electricity generation or electricity. Okay. So what we have to understand here is that thermal electricity producing states bear a disappropriate pollution burden when compared to consuming states. So for example, let us see, I am a XYZ state. If I am producing electricity and I am doing a lot of pollution and I am selling this particular electricity to some other states. So who is supposed to take the burden? The producing state or the consuming state? Okay, so there is a kind of a disappropriate pollution burden when it is compared to the consumer state. So this is what they're trying to tell. So all the burden is put on me and not on the other state. So for example, if I am producing the electricity using the thermal power plant and I am selling it to some other state, and all the burden is on me and not on the consuming state, but I am not consuming it, I'm giving it to somebody else. So the consumer state should also have the equal amount of share. That is what is being discussed in this particular article. Okay. Now see, there are states with the highest thermal power sharing include Tripura 96.96, Bihar 95.57, Chhattisgarh, Jharkhand, Delhi, and West Bengal. These states produce larger amount of electricity but do not consume it at all. So in this particular paragraph, they're talking about the same thing, that how much, you know, each and every state has been producing. For example, Tripura has the highest. Okay, and you can see Uttar Pradesh. So these are the states, they are producing so much of amount of electricity, but they are not using it for themselves. Not all the electricity generated in these states are fully utilized inside the states. Bihar sold so much of electricity in 2022, 2023. So you can see that these states these states which are producing so much amount of electricity, but they are not using it all. So that is something that we need to understand. Now, electricity trade between different states, how does it happen? See, Niti Ayoga date or Niti Ayoga shows that Chhattisgarh is the highest net seller of electricity among all the Indian states with 535.29 megawatts in 2022-2023, followed by Madhya Pradesh, Himachal Pradesh, Rajasthan, Odisha, Meghalaya. These are the states where centrally produced more uh, thermal electricity and sells to others. Gujarat is highest importer. So you need to understand Gujarat, even after producing its own, it is still depending on other states. And there are some states which are able to produce more and they're able to sell. So who is largest consumer? It is Gujarat. And who is the largest seller? It is your Chhattisgarh, right? So these are some things that we need to understand. While some states benefit from buying electricity, others suffer from pollution caused by thermal power plants. So here you can see, because some of them are producing and some of them are consuming. So because of all this, what is happening here is there is a lot of uh, benefits that whoever is buying or electricity and suffering. So while some states are benefiting from buying electricity and others are suffering the pollution. Now, and there is no compensation. So let us see lack of compensation for producing states. Now, we do not have Indian electricity and environmental regulatory structure do not compensate states that generate electricity from centrally sectored thermal power plant. Therefore, net export states of central sector power producing bear the burden of all the pollution, and the net importing states enjoy the clean electricity. For example, see what is it trying to tell here? There is no proper compensation that is given. For example, if I am Uttar Pradesh, sorry, Chhattisgarh, I am producing the electricity, okay, and I am giving it to whom? Gujarat. Now I am producing, so the pollution is in my state. I am not enjoying any benefits. I am facing what burden? And Gujarat, who is importing all the electricity, okay, so automatically this is enjoying what? It is enjoying the cleaner energy. The reason is because it was not produced in that particular state, it was produced in some other or generated in other states, right? So hence, what is happening here is you can see that the regulatory structure is not compensating the states that are generating the electricity, and it is somebody else who is enjoying the cleaner energy, right? So this is what this is trying to tell. Central sector thermal power plant are majorly producing in coal-rich states such as Chhattisgarh, Jharkhand, and Odisha. Even though coal-rich states produce the maximum thermal electricity, per capita electricity consumption remains sustainably lower than the other economically better off states. Thus, the coal-rich states face a new form of resource curse. So here you can see that because, see, coal is not available everywhere. Okay, so we all have understood that if something is present in a particular place, there it will be utilized more. So similarly, Jharkhand, Chhattisgarh, Orissa, there you find a lot of coal, and hence the production of electricity from coal is higher in this particular states. But what is happening here is even though they are producing higher amount of electricity, they are still having this resource curse. Okay, because of the resources present, and that is why it is a kind of a curse because they're able to produce the electricity, but they are anyways getting a pollution burden as well, right? So under the corporate social responsibility scheme, although the thermal power plant producing companies spend a small amount of funds in developing their periphery, this is a far off compensation for environmental damage. The National Clean Energy and Environment Fund was created to promote renewable energy and assist states to cleaner energy. See, anyways, this is a small thing, and even any private sector which is producing this particular electricity, they are doing some kind of small social responsibility, but that's very, very small. That's something that we have to understand. Electricity is a concurrent subject. Okay, so we all know when you have discussed polity, there are three different subjects. One is the state list or union list, you can say, and then we have state list, and then we have concurrent list, right? Concurrent list means both the state and the center have got equal kind of what you mean to say power, right? So we all have discussed that. Entry 38 of list 3, that is in the concurrent list of 7th schedule of the Indian Constitution, which allows both the center and the state governments to legislate on electricity matters. States are constitutionally permitted to levy taxes on electricity consumption on sale, but no, not on generation. So here, whatever sharing is there or whatever thing is there, it is dependent only on what? It is depending only on consumption and sale, not on the generation. It is not talking about which state is generating, which state is not generating. Okay. It is only talking about how you can sell it, how you can consume it. Okay. Similarly, the central government does not impose any specific tax on electricity production as well. So if any state is producing any electricity, there is no any kind of tax that is being charged by the central government. So these are some of the loopholes you can say, right? So in October 2023, the Ministry of Power issued a directive that prohibits state government from levying additional taxes or duties on electricity generation, clarifying the constitutional boundaries. As a commodity, electricity is exempted from goods and service tax. Service related to electricity transmission or distribution by utilizers are also GST exempted. Therefore, consuming states receive the electricity duty levied on electricity states. The electricity states producing or electricity producing states do not get any extra tax revenue, but only burden. So here you can see that it is exempting this particular, what you mean to say, electricity production from the GST, or because of this, what is happening here is, so you need to understand that electricity producing states do not get any extra revenue because it is exempting it from goods and service tax, only getting the burden of the pollution. This is something that we need to understand, right? So next thing, what they're going to come up with: electricity producing and consumed within the state in internalize all the benefit and cost. However, when the electricity is produced in one state and consumed in another, it creates a pure negative externality for producing states. In such situations, states producing thermal power under the central sector should be compensated for all the electricity consumed by the other states. So here, what is the formula or what is the solution? Instead of, putting all the burden on one particular state which is producing it, what we need to do here is we need to share this. The situation should go different. This can be done in two ways. What are the two ways? States with where central sector power plants are located can tax thermal power generation. So they should have a separate tax. Otherwise, the union government can collect and transfer the generation tax to the producing state. So, for example, if I am producing this particular electricity, this tax should be collected and that tax should be given to that particular state who is producing it. Okay. The other mechanism would be compensation mechanism through the finance commissions. So we all know we have finance commissions. The finance commission has previously recommended environment grants and devolution of funds. So upcoming 16th finance commission should design a fiscal roadmap to support thermal, power plant. So what is going to happen here is this finance commission should make sure that whichever state is producing and selling it to some other state, maybe they are getting some kind of compensation. Okay, because they are not using it for themselves and they're giving it to somebody else. And the state which is consuming it will have to carry some of the burden. So this is the other way around that they can basically do. So here that's what is mentioned here. That is nothing but the 16th Finance Commission should seriously consider India's international climate commitments and develop a fiscal roadmap to achieve these goals. Whatever the mechanism, thermal power producing states under the central sector scheme should be compensated adequately for carrying the burden of other states' electricity consumption. So what they're trying to say here is that whatever Gujarat is consuming, its burden should not be kept only on Gujarat. It should also be sent to a little bit of Chhattisgarh. The compensation should be given to Chhattisgarh for producing more amount of electricity and giving it to some other state. So this is what is all about this particular article. Now let us see the next important article that we have. That is, it's one of the important trillium facts. That is nothing but China's East reactor keeps a fire of magnetic fusion burning. So let us see what is this all about. So first thing we have to understand that scientists in China have reported that East reactor sustain a plasma at 1000 million degrees Celsius for 1.006 seconds in nuclear fusion reactor called as Experiment Advanced Superconducting Tokamak. So So here, what they're trying to say here is on January 20, Chinese scientists have reported that they were able to maintain some of the temperature. So this is a kind of an artificial sun. Okay, that is the nuclear fission reactor experiment that they're trying to do. And they were able to, maintain the temperature of 100 million degrees Celsius for about how much seconds? 1.066 seconds, which is a good thing. I mean, it's a very huge thing that we have to understand. Okay, now we'll discuss more in detail about this. So this was a major milestone in the quest of nuclear fission, surpassing the previous record. So in the previous record, it was only 403 seconds in 2023, but recently it is 1.006 seconds, means they've already crossed 1 minute, which is a good thing. Okay. Now, everything that we need to know about this particular thing is what is this EAST? That is Experimental Advanced Superconducting Tokamak. Okay, that is what is EAST. Okay. Now we'll understand this a little bit about this in detail. Location and operation. EAST is located in China and is basically it is located in a place called, I'm sorry with the pronunciation, but yes, there is a place. I'm so sorry, just give me a minute. There's a place called Hefi, okay, in China, and is operated by Hefi Institutes of Physical Science, Chinese Academy of Science. Okay, and what is the major purpose of this? It is to serve an experimental nuclear fission reactor to test and refine technologies, right? So the design is it's the only world's tokamak reactor which is both toroidal and polodial. Okay, we'll discuss what is this toroidal and polodial, don't worry. Superconducting magnetic field ensuring better plasma confinement. Okay, so what is the milestone that they've come up with? The first important milestone that we need to understand is on 20 Jan 2025, it has sustained the plasma of 100 million degrees for 1.006 seconds, setting a new world record. Okay, and the process that is there here is fusion process. It uses magnetic confinement to hold the deuterium and tritium plasma and facilitate fusion reactors. So we'll understand this. See, in 1993, the physicists Otto Hahn and Strassmann found out the energy produced when the nucleus of an atom breaks apart. The process at Lisa Metritt and Otto French explained in a year later, and the process called fission. Only 4 years later, the physicists used this principle to build and operate the world's first reactor, which is a sustainable fission reactor. See, in 9th standard and 10th standard science, you might have studied that if there is an atom, we all know what is an atom. Okay, if you do not know, it is the smallest particle which cannot be further divided. Okay, if you take any particular element and if you divide it further, you will come up to a smallest element, and I mean smallest part. At that smallest part is your atom. And when these atoms have three things in them, and that is nothing but they have protons, electrons, and neutrons. Okay. So hence, basically what happens is in the nucleus, you have your protons and neutrons, and electrons are there in the outer orbit. This is basics of atom. Whenever there is this particular energy, that proton is reduced or proton is put inside, basically what happens is some kind of energy is being generated. So this is basically what nuclear energy. And nuclear energy, there are two types. One is called nuclear fission. Fission means basically one thing is becoming two different things. Like one bigger atom is getting divided into smaller atoms. That is dip separation. And there's one more thing which is called fusion. Fusion is something which happens in the sun, wherein your hydrogen gets combined together and forms helium. Okay, this is an example where two things are coming together. So they are trying to have a kind of a artificial sun. This particular reactor is nothing but is an example of an artificial sun. So we'll discuss about this. By this, physicists also knew that the energy is also produced when two atom nuclei fuse together, and this process is called as fission. Nuclear fission produces harmful radioactive waste, whereas nuclear fission does not. This is why developing a nuclear fission reactor has become an important technology goal for the world, keenly interesting for the new source of cleaner energy. See, as I already told you, in fission, there's a big atom that is getting divided into two. Maybe I will use this and this will become what? It will become a waste. But if it is fusion, so if I am taking one hydrogen, making a helium, this is also useful. So hence what is going to happen is this kind of a fusion reaction is something that we all want to, focus upon so that we are having a cleaner energy. Right? So this is an important task. Now, the tritanium problem. The problem is the amount of energy required to start and sustain the fusion reaction. A nuclear fission reaction can be kicked off by shooting neutrons for sustainable energy at an atom of unstable nuclei like uranium. For fusion, it occurs. However, the nuclei need to be exposed to a temperature for at least around. So see, look, I know that fusion is good, but problem is not easy. We need to understand it's not easy. The reason why it is not easy is if you want to make fission reaction, you need to make sure that any nuclei supposed to be exposed to how much million degrees Celsius? 100 million degrees Celsius of temperature. Okay, it's not that easy. This is something that we need to understand. The light nucleus in nature is hydrogen consisting of single proton. The isotope of hydrogen is called deuterium and has protons. It has one proton and one neutron and in its nucleus. The nucleus of other isotope is tritanium, which has one proton and two neutrons. Deuterium-deuterium fusion requires high temperature to begin that deuterium-tritanium fusion. This is because of an extra neutron of tritanium nucleus help overcome the repulsion of charge like charges between the protons. So as I already told you that, see, when it is hydrogen has got only one electron. In the nucleus, it has got one proton, and if it has got one neutron, then it is called deuterium. And if it has got one proton, and if it has got two neutrons, then it is called tritium. So if you want to, collide this, so this has to get converted to tritium. And how can it get converted? You need one extra neutron. And to get this one extra neutron, you need a lot of energy, right? So this is something scientific that you need to understand here. The fission of deuterium and tritium nucleus create a non-radioactive helium-4. So we are getting a helium-4 nucleus, a neutron, and 17.6 million, sorry, 17.6 MeV of energy. So this is this much of energy, which is significant. The neutron can be directed to blanket of material surrounded to the reactor and capture it and release more heat. So when you're able to capture this particular thing, it will be releasing more heat, and this heat can be, utilized for further generation of electricity, etc. While deuterium is abundant in seawater, okay, there is no natural deposits of tritium. So we get a lot of deuterium, but we will not get a lot of tritium, which is very hard to produce. At present, mostly created by byproduct of heavy water fission reactors in Canada, India, and South Korea. So where can we get this particular thing? It is a byproduct of fission reaction in Canada, India, and South Korea. This is something that we can understand. The next important thing that we need to understand is there's a lot of other issues also, like when it comes to this particular thing, and that is the temperature problem. Yet another challenge for nuclear fission is temperature. For both the nuclei to fuse, two things are needed to happen. The light charges of the nuclei due to the protons need to overcome their particle, need to come within 1 ferrometer to each other so that they can bond. Means they should be very, very close. This is something that they're trying to tell, first thing, so that they can bond with each other using the strong nuclear forces. This force is the strongest fundamental force in the nature and responsible for keeping protons, neutrons together in the nucleus atom. But the flip side, the only act across very short distance. So 1 ferrometer is roughly 1/4 of the width of the carbon nucleus. Very, very small, very, 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 very close they have to be. Okay. This is why the nuclei need to be heated to such a high temperature to give that enough energy to overcome this repulsion and get closer to each other. So why are we giving this much amount of temperature? So that they're coming very close and they're able to bond each other. And that is the reason we are able to give this much amount of heat, or this much amount of temperature is supposed to be given to them. This different reactor designed to achieve, there is a different reactor design that is there to achieve this nuclear fission by meeting these conditions. One set of design involves a use of tokamak, a donut-shaped vessel where nuclei is confined like a cage and made to fuse. So there are different ways also. This is another example. Now, what is a magnetic cage? That this cage they're talking about. Inside a vessel, a deuterium gas is exposed for around 20 million degrees Celsius, where the matter exists in the plasma state. Plasma. There's a fourth state of matter that we have, and that is the plasma state. Okay. The changed particle or the charged particle is stripped from their respective atoms and floated around freely. Next, the particle are exposed to very strong magnetic field that act like an invisible net, trapping the particle along the field lines. This method is called magnetic confinement. So I was talking about magnetic confinement. What we're trying to do here is we are having a vessel. Inside this particular vessel, what we're trying to do is we're trying to put a gas in a plasma state, that is deuterium gas, and we are trying to expose it around this much amount of degrees Celsius. So hence what happens here is the charged particles are stripped from their respective, so they are coming out from their respective atoms and floating freely. Next is what they're doing is the particle are exposed to very strong magnetic field. So they are able to, put a magnetic field that acts like an invisible net. And they trap this, and this, because we are, exposing them to a magnetic field, hence it's also called as magnetic confinement. Engineers prefer to use electromagnets, okay, special material that generate magnetic field when the current has passed through wires collided around them. So to create these fields, because these field strength only depends upon the amount of current in the wires. So these wires are also superconducting. They can carry electricity with zero resistance if they are cooled down to very low temperature, which is achieved by blanketing them with liquid nitrogen and helium. So this is very, very important. With what we can, achieve this particular superconductivity, that is when we put them around, when we are blanketing them around liquid nitrogen and helium, what basically happens here is we are able to, get superconductivity. See, there are some words now. I'll tell you what. Listen. So in class 6 standard NCERT of science, if you have studied, there is an experiment. You take a nail, okay, and put a copper wire to it. Connect this with a battery. Okay, connect this with a battery. If you connect this with battery, this particular nail will start acting like a magnet. And this is called as electromagnetic effect. Okay, so what is this? If there is electricity, so this particular experiment is saying that if I have electricity, I can convert any particular metal into a magnet. So there are some metals which can do this, and they are called ferromagnets. So uh, because this situation is there, so here I hope you're understanding. If I am able to give more amount of temperature, why more amount of temperature is given? So that there is a magnetic field that is getting created. And this magnetic field or magnetic confinement is going to help me get my required fission reaction. Now I hope you're understanding why do you require this much million degrees Celsius is because we want to achieve this kind of situation wherein we are having this magnetic confinement. Okay. So inside East, both toroidal and palladial magnetic fields are generated by superconducting electromagnet, which are currently the world's only tokamak with this feature. Toroidal magnetic field follows a donut-shaped reactor. So what is this? It is donut shape like this. Okay. While the palladial follows the centric. See, if it is following this kind of a path, okay, the magnetic field is this kind of a path, then it is called as toroidal, and if it is palladial, it is kind of centric, means, centered. Together, they keep the particles within from drifting from the vessel walls and collapsing the plasma. Instead, they move in a spiral pattern through the vessel with opportunity to collide with each other. So this kind of arrangement does not allow them to go out, and they are trying to, rotate there only so that they can collide. The palladial effect or field also includes the electric current in the plasma. When parts of the plasma resists to flow this current, heat is produced, adding the energy that is required to achieve the fusion as well, right? So there are series of records that they have been created. Though the years, East has been setting a series of record and validating the technologies used to achieve them. It was the first tokamak to sustain the plasma in a higher confinement, around 50 million degrees Celsius and more for more than 60 seconds in 2016. So you can see these are the records that they've been breaking in the last years. And the recent record that we have to understand here is that it has been, able to sustain this much amount of heat for 1.006 seconds. For this achievement, operator provides twice the thermal power in the east as they did it for 2023 feet, allowing the plasma to retain stable for longer. So this is what they've done. Now, what are the alternatives or the need of alternatives? So why are we trying to have this kind of alternatives? So automatically it is because, see, east is success as important, but feature because the later has come under criticism for the delayed timelines and cost overturns. Will the bill already upward for the Europes? So see, what is the issue that when it comes to this kind of thing? The first thing that we have to understand here is that we are able to do this. What is the amount of the money that is invested to, create this particular tokamak? If we are able to generate electricity from this particular thing, what are we trying to do? Can we sell it for the lower cost? Automatically, no, it is going to go for the higher cost itself. So this is some of the issue that it comes, for this kind of alternatives. Some research groups have also been trying to achieve the nuclear fusion using methods of require for fewer but still considerable resources. For example, on another alternative of achieving magnetic confinement device is stellarator, whereas tokamak has simple donut shape and stellarator has more twisted designs that is harder to build and operate. But its advantage is that it does away with a need of palladial magnetic field to achieve twist magnetic fields. So hence there are different other techniques also, but again they are very costly. Other designs do away with magnetic confinement altogether. One technique, for example, is a pellet of deuterium, and deuterium is hit with lesser beams of extreme power. Whereas the deuterium nucleus is one proton, one neutron, the deuterium has one proton, two neutron. Where the beams strike the pellet, the energy caused by the nucleus to compress and fuse, releasing more energy. This heat from the reactor could then be diverted to a pool of water, generated steam, and then turbine and produce electricity. So this is the just process how the electricity can be produced. So see, I know this particular topic is a little difficult. Anyways, you will study about tokamak more in detail in science and technology. See, we have to understand there is a separate topic called as nuclear energy. Okay. In the nuclear energy topic, you will study there are two types of energy or two types of things, that is fusion and fission. So you will study more about this. In India also, we'll study more about nuclear reactors. This is a science and technology based topic. So if you are not from a science background, you may feel it a little difficult. So I would suggest you to do some kind of research based on nuclear energy. That is when you will be able to understand more in detail this particular topic. But anyways, I have tried to explain you from the basics how this particular magnetic field can be used using electricity, etc. Try to, do a little more research on this particular topic. If you have any suggestions, please put it in the comment section. I'll see you guys in tomorrow's class. Thank you so much.